Hi, welcome back to McClutchy Maths. My name is Natalie McClutchy and today we are completing our How to Write a PSMT series by looking at communication, looking at vocabulary and conventions. And this video is aimed at students of mathematics in Queensland, Australia. And first of all, let's hit that ISMG, the Instrument Specific Marking Guide. We are focused on this top point in the communication box, the correct use of appropriate technical vocabulary, procedural vocabulary, and conventions to develop our response. How do we hit that particular point and make sure we get 4 out of 4 for communicate? Well, in this video, we're going to talk firstly about technical vocabulary, procedural vocabulary next, and then what are conventions. As you may be wondering, how do you achieve 4 out of 4? So let's look firstly at technical vocabulary. Now, the definition from the QCAA are that technical vocabulary are terms with a precise mathematical meaning, such as categorical data, chain rule, decimal fraction, and so on. There's quite a few words there. They could also be everyday words that we use in a mathematical context, like capacity. So a capacity, when we talk about it in mathematics, is all about how much liquid a three-dimensional shape can contain. But when we talk about capacity of a human being, we're talking about their abilities. So we need to make sure we're using the mathematical word the right way in the sentence. So we're using our mathematical definitions correctly. For example, we might be demonstrating that technical vocabulary by showing that we know the difference between volume and surface area by using the correct units of measurement and applying the correct rule in the correct way to demonstrate that. So sometimes students do get surface area and volume mixed up. So making sure that we're using the correct vocabulary to describe our different situations. Other ways were, for example, when we're talking about in bivariate data analysis in senior mathematics, when we're looking at Pearson's correlation coefficient R and also the coefficient of determination R squared. Now they're both quite similar, one's squared, one's not, but they are actually quite different in the way that we talk about them. And a technical vocabulary, for example, with R squared, we're talking about that variability in our Y context that is explained by the variability in the X context, and we need to actually use the context there. So doing that appropriately is all about using correct and accurate technical vocabulary. So we've just talked about that there in that terms of that variability, using that correct language. So we don't have to get fancy and technical and write it differently and use our thesaurus and our synonyms. No, just be simple with the language and use the language correctly. Knowing the difference for bivariate data between correlation and causation, and trying to avoid using the word causation because we're not talking about things causing one another, we're talking about relationship and association. So knowing those right words that we need to use to discuss the results from our scatter plots. Let's talk more now about procedural vocabulary. These are instructional terms that we use in a mathematical context. You may also know them as cognitive verbs, is what we now is our buzzword: calculate, convert, determine. They are all doing words, verbs that are things that we do in mathematics, and we use them in different ways for different situations. So we're using those verbs correctly in the right context. For example, we solve equations, but we don't solve expressions because there's no equal sign. Measurements are converted from meters to centimeters to millimeters and so on. We substitute into an equation. This is a big one I see students writing that they subbed in or that they're subbing into an equation. We don't, we substitute. So use the language appropriately. We sketch and we plot graphs. We don't draw them as such. So using that correct verb there. Explaining what we're going to do before we do it is also a part of that procedural vocabulary, and it does improve our communication grade and the flow of our report. Here's an example from the QCAA. They've actually drawn the residual plot, but before they jumped in and just drew it, they explained what it is. So they said it's calculating residual values and producing a residual plot is a more reliable method of verifying if a relationship between two variables is a viable option. So not only is this justifying their mathematical decisions, but it's also explaining what they're going to do before they do it. Now, this does not have to be a book that you're writing to explain, but a simple sentence that says what a scatter plot is before you draw the scatter plot, or that says what a histogram is before you then go and develop the histogram, to explain what you're doing and why you're doing it. That's all part of your procedural vocabulary. And then we fall into something called conventions. And this is the general agreed way that something is done. So for mathematics, that's all about the symbols, the abbreviations, the usage, and the way we set out our working. So some conventions we have in mathematics includes the way we write algebra. For example, we write x squared, not x with a big 2. So we use what's called a superscript, which is like a power and index, not the big number next to it. So it's very careful that we write using equation editor correctly. With algebra, we typically don't write a 1 in front of our x's. That's what's also known as a convention. We usually put our numbers, and when we're using algebra, the coefficient, which is our number that goes out the front, it goes out the front, and then we put all of our letters, which are our pronumerals, we put those in alphabetical order. That's a typical convention for algebra as well. So we would write 4xy, not 4yx, and not xy4. Now, in reality, they're all multiplied by each other, and we don't really need to worry about what order that we multiply things in, but this is all about the correct conventions, the things that are generally agreed upon that is the way we do them. Okay, other things with the use of equality symbols, and this is a big one with mathematics. So our convention firstly is that our working is left aligned. Now I know when you use equation editor always centers it. You can actually override that by putting your cursor in front of the working and then left, using the little left alignment button to left align your working, and it looks a lot better. That's an important thing. Convention is to left align your working. And that we only use one equal sign for every line of working. So here's an example from a student where they've used one equal sign in the first row, but in the second row they've said that equals 15 take away 12, which equals 5x plus 12 take away 12. Well, 15 take away 12 is 3, and that is not equal to 5x plus 12 take away 12. So it's really important that you only have one equal sign in your line of working, and then it becomes an equation, not just multiple statements of equality. You'll notice in the third line they've also got 3 equal signs as well. They're saying that 3 is equal to 5x, which is equal to 3/5. Well, we know 3 is not equal to 3/5. So it's really important that you make sure that you only have one equal sign in any line of working. The use of words to communicate your working is also really important, particularly, for example, if you're doing multiple calculations. You might be, for example, calculating the perimeter around a fence, around a yard, and then you might move on then to calculate how many palings of fence that you need. There are 2 separate calculations. One is of the perimeter, and then following that calculation you've got the next calculation, which is working out how many palings you need. But it isn't all the one piece of working, so having a simple sentence to separate each part of the working is a great idea. Here's another example using algebra. This student is actually using some communication to communicate what they're doing and why they're doing it. It's not always necessary, particularly in senior, to explain each of these steps, but sometimes it can be very helpful to explain to the reader what you're doing and why. Some other conventions include money. Money has a dollar sign, and it's always rounded to 2 decimal places for the cents. Often your calculator, when you've got something where it's in whole 10 cents amounts, it will produce a result such as 2.1. You need to remember to write that as $2.10 because that's what 2.1 is in the context of money. So make sure that you're using 2 decimal places. But also, if you've got really, really large amounts, and we're talking hundreds of thousands of dollars, maybe you're calculating a mortgage for your financial mathematics assignment in Essential Maths. Well, you're not going to write $485,689.93. If you're going to discuss it, you would then round that to the nearest dollar, which would be more appropriate. Make sure you give your final answer with the correct units of measurement, and that you ensure that any time you talk about that measurement anywhere in your assignment, you use the units of measurement to talk about it. It makes the numbers make more sense. And you can see in this example, firstly, the rounding's an issue. They've got these rounding to ridiculous numbers when convention is to round those off. For example, we're talking about actual measurements here in centimeters. Now, it's virtually impossible to measure someone's nose to 10 decimal places on a normal ruler. So it would not make sense to have that many decimal points. But also, we're talking about measurements of deviation in centimeters or meters or millimeters. It's really important to make sure that you've communicated that appropriately. Graphs as well. This is another one where conventions come into taking place, is graphs. We've got those conventions for how we actually draw them. So we need a title, we need axis titles, and those axis titles should include our units of measurement as well. In this particular example, we've got mouth width and nose width, but are these measured in millimeters or are they measured in centimeters? We need to explain that. And there needs to be appropriate scaling as well, and this falls into the area of conventions. Here's another example of a student who has not used any titles whatsoever. You've got no idea what that graph's about, and neither do I. So make sure you've always got those titles. That's really important. Well, that's all we have time for today. I hope this has been a helpful video for you to understand a little bit more about what's expected of communication. If you liked this video, follow us on Facebook and Instagram, hit the notifications button, subscribe to the channel, and tell someone, even tell us in the comments if you found this helpful. That really means all the world to me for all the work that I put into this channel. And if you've got any questions at all, you need a little help or a bit of a nudge in the right direction, you can contact us at mcclatchymaths@yahoo.com or direct message us on Facebook and Instagram. I'd like to say thank you so much for watching me here at the channel and for following through with our PSMT series. I'm Natalie McClatchy. Have a wonderful day.